Welcome to another NCSA Learn Explainer. NCSA stands for the National Cybersecurity Agency of the Maldives. Today, we're going to dive into the hidden world of something called operational technology, or OT for short. These are the invisible systems that run literally everything around us, our power, our water, and when they fail, it's not just a computer crashing. We're talking about real, physical world consequences. So to get our heads around this, let's start with something we all get: cars. Think about how far car safety has come. We went from, basic manual controls to cars that have airbags, anti-lock brakes, and can even stop themselves to avoid an accident. It's an absolutely massive leap in safety, right? Well, what if I told you that the technology running our nation's most critical infrastructure hasn't really kept up that same pace? All right, so what is this stuff we're talking about? It's operational technology. Think of it as the invisible brain that controls the physical world. It's what keeps the lights on, what makes sure clean water comes out of your tap. It's the behind-the-scenes magic of modern life. So here's the formal definition. But really, let's just break it down. Your computer or phone, that's information technology, or IT. It manages data. OT, on the other hand, does things. It's the hardware and software that actually makes stuff happen. It spins turbines, opens valves, and keeps things running in the physical world right now in real time. And you can find OT just about everywhere. Right here in the Maldives, it's managing our power grids and our absolutely vital water management systems. It's in factories, in airports, even in the systems that control the lights and air conditioning in big buildings. These systems are truly the backbone of our entire modern world. Now, this slide is key because it shows the huge difference between IT and OT. For IT, it's all about protecting data, keeping it secret, accurate, and available. But for OT, the priorities are completely different. The absolute #1 mission is safety. You just can't have a power plant trip offline. The system has to be reliable, and above all else, it has to be safe. And that focus on just keep running no matter what has created a really interesting problem. A lot of these OT systems are decades old. They were built to be isolated and to just work, kind of like a classic car. They're dependable for sure, but they were never designed with modern cyber threats in mind. This means security patches and updates happen at a snail's pace, if they happen at all. And this quote right here just hits the nail on the head. The second you connect these old systems to a modern network, a cyber problem instantly becomes a physical safety problem. A lack of digital security makes the whole system physically unsafe. It's that simple and that serious. And believe me, this isn't just a what-if scenario. The consequences are terrifyingly real. We've seen everything from simple sensor failures leading to massive explosions, to targeted cyber attacks like Stuxnet that physically destroyed industrial equipment. And of course, the tragic Boeing 737 MAX crashes were a heartbreaking example of software and sensor failures in an OT system. When OT goes wrong, the impact is real and devastating. So you might be asking yourself, how did we get here? Weren't these systems supposed to be isolated and protected? Well, for a very long time, they were. You had the corporate IT world over here and the industrial OT world over there, and they never, ever talked to each other. This separation was known as the air gap, and it was a literal physical barrier. There were no network cables connecting the factory floor to the front office. It was a pretty simple and honestly a pretty effective way to keep things secure. But then we wanted more efficiency. We wanted more data. We wanted to monitor things remotely. And so we started knocking down that wall. We connected these two worlds. And in doing so, we basically built a digital highway for cyber threats to travel right from the internet into the heart of our physical control systems. The result is what we in the biz call a much larger attack surface. Think of it like this. We've taken a secure fortress and added a whole bunch of new doors and windows. Every new connection is another potential way for an attacker to get in and cause serious disruption to our most essential services. Okay, so that's the problem, and it's a big one. But here's the good news. We aren't helpless here. There's actually a very clear blueprint that critical infrastructure providers can follow to start making these systems much, much safer. And it all boils down to a really simple 3-step framework. It's easy to remember. First, you have to see your system. Second, you secure your zones. And third, you enforce something called zero trust. So let's break down what each of those really means.
All right, step one is C, and this is so fundamental. You absolutely cannot protect what you don't know you have. It means you need a complete list of every single device on your network, every sensor, controller, computer, you name it. You have to know what it is, what software it's running, and most importantly, find any unauthorized shadow devices that someone might have plugged in.
Next up, secure your zones. Remember that physical air gap we talked about? Well, since that's gone, we have to rebuild those walls digitally. And we do that with something called network segmentation. The idea is to chop up the network into smaller, isolated zones. That way, if an attacker gets into one area, they're trapped there. They can't easily spread to the rest of the system. Now, the industry standard for doing this is called the Purdue model. It's basically a guide for organizing the network into layers. As you can see, way down at the bottom, where the actual physical stuff is happening, you need total trust. But as you move up the levels toward the business network, that trust level has to drop, all the way to 0. You trust absolutely nothing coming from the outside world by default. And that idea flows perfectly into our final step, enforce zero trust. The motto here is simple, but it is so powerful. Never trust, always verify. Now, for OT, this is the really cool part. It's not just about verifying people, it's about verifying the machines and the commands they send. Before a controller is allowed to open a valve, the system asks, wait a minute, is this device actually authorized to tell me to do that? And it checks every single time. So, as we start to wrap this all up, I want to bring it back to the one thing that truly matters. When we talk about cybersecurity for OT, we're not just talking about protecting data or preventing downtime. We are talking about protecting human lives. And you don't have to take my word for it. The biggest cybersecurity agencies in the world, CISA, the NSA, all their partners, they've all put out principles that start with this one core idea. Safety is paramount. It's the absolute non-negotiable priority. So if you only remember one thing from this whole explainer, please let it be this. The number one priority for any and all operational technology must always be safety. Full stop. End of story. And that leaves us with one final crucial question to think about. All these invisible systems that we depend on every single day are getting smarter and more connected. So the real question for all of us is, are we doing enough to make sure that they're also getting safer?